Bismillahirrahmanirrahim. Welcome to the second part of this topic, which is the right triangle trigonometry. We said that if we have a right triangle with two sides given by the adjacent or hypotenuse or the opposite, we can find the 6 ratios between the sides of the right triangle. We define the right triangle as a triangle with one angle equal to 90 degrees. And last time we defined this trigonometric function to be one of the 6 ratios of the size of the right triangle. And we said that if we have theta, which is acute angle, not equal to 90, then we have 6 trigonometric functions of theta, and these are given by sine theta, cosine theta, tangent, secant, and cosecant, and cotangent, and cosecant. So we have sine theta, which is given by the opposite divided by the hypotenuse. We have cosine theta, that will be adjacent, and divided by the hypotenuse. We have tangent, which is equal to the opposite divided by the adjacent, or the cotangent, which is equal to the adjacent divided by the opposite. Secant is equal to the hypotenuse divided by the adjacent, and cosecant, which is equal to hypotenuse divided by the opposite. These are the 6 trigonometric functions. Now, last time, we discussed how to find these if you are given two sides of a right triangle, given the hypotenuse and the opposite, or hypotenuse and the adjacent, or opposite and the adjacent of the angle theta. We need just to use the Pythagorean theorem to find the missing side, and then we can find the 6 trigonometric functions. But sometimes the question can be given in reverse. You might be given the trigonometric function, and we need to find, or one of the 6 trigonometric functions, and we need to find the other 5. Like this example. Let theta be an acute angle of a right triangle for which sine theta equal to 3/5. And we need to find tangent of theta, secant theta, and cosine theta. So what we are given, only sine theta, which is equal to 3/5. And we need to find the other trigonometric function, or the remaining 3 given in this exercise. So from the given function, which is sine theta equal to 3/5. From the definition of sine theta, we go back. We know sine theta equal to the opposite divided by the hypotenuse. It is opposite divided by the hypotenuse. So it is length of the opposite divided by hypotenuse. So we can see that the missing one is the adjacent. So if we graph right triangle, and this is theta, we have opposite that equal to 3. And the hypotenuse is equal to 5. So the missing one is the adjacent. And we know from the Pythagorean theorem that the adjacent equal to square root of hypotenuse square minus opposite square, which is equal to 5 square minus 3 square. This is equal to 25 minus 9 is equal to 16, which is equal to 4. So the adjacent equal to 4. From this one, we can find tangent theta, secant theta, and cosine theta. So starting with the first one, number 13, I need to find tangent theta. We know that tangent theta equal to opposite divided by adjacent, which is equal to, opposite is 3 divided by the adjacent equal to 4. So it is 3/4. For the second one, secant theta, it is defined by the hypotenuse divided by the adjacent, which is equal to 5/4. So secant of theta equal to 5/4. Next one, we need to find cosine theta, number 15. Cosine theta equal to the adjacent divided by the hypotenuse. That will be equal to 4/5. So this is the idea of finding missing trigonometric function if you are given one of the 6 trigonometric functions. Or what we need, just we need to define the adjacent, opposite, and the hypotenuse to find the remaining or the missing one. Let's take another one. Suppose that we have, for example, this question. Let's take this problem. We need to, or you are given that theta is an acute angle of a right triangle for which tangent theta equal to 4/3. And we need to find sine theta, cotangent of theta, and secant of theta. So it is the same idea. We are given tangent. Tangent theta is defined to be opposite divided by the adjacent. So if we, what is equal to 4/3, it means the opposite equal to 4 and adjacent equal to 3. So if we graph this triangle, this is theta, the opposite equal to 4, adjacent is equal to 3. So the missing one is the hypotenuse. So we need to find the hypotenuse using the Pythagorean theorem, which is equal to the square root of opposite square plus adjacent square. And this is equal to, in the Pythagorean theorem, if the missing one, if the missing is the hypotenuse, then we add adjacent square plus opposite square. If the missing is one of the other side, maybe the opposite or the adjacent, then it is hypotenuse square minus. If we are looking for the largest side, we add. If we are looking for one of the short sides, either the opposite or the adjacent, we subtract. So we have the opposite equal to 4 square plus adjacent is 3 square. And this will give me 16 plus 9, that will be 25, which is equal to 5. So the hypotenuse is equal to 5. So I can find now the sine, cotangent, and secant. Sine theta is defined to be opposite divided by the hypotenuse, which is equal to 4/5. It is 4/5. Second one, cotangent theta equal to adjacent divided by the opposite. It is the opposite of the tangent. Which is equal to, the adjacent is 3 divided by 4. And this is equal to 1/tangent. I mentioned this before in the first part that we said that cotangent is the reciprocal of the tangent. And question number 18, we need to find secant of theta. Secant of theta is defined to be the hypotenuse divided by the adjacent. that will be equal to 5/3. So this is the secant of theta equal to 5/3. So this is the idea of how to find trigonometric functions if you are given one of the 6 ratios. So we have two types. Either you will be given triangle, right angle, and you are given the adjacent or the opposite and hypotenuse. Two sides must be given. Or you might be given one of the trigonometric function and we need to find some other trigonometric function. And this is the idea of how to find them.